Caroline, and I'm going to be talking about how to name compounds tonight. Oh look, here's one. Salt. Okay, we're done here. Salt. Psych!
Go.
So, yes, salt is a compound. It's actually an ionic compound, but its chemical name is not salt. So, before I teach you guys how to name an ionic compound, you need to know some basic principles. Okay, so first of all, when you look at your periodic table, there's 3 basic sections, just if you could bring it down to the most bare minimum basics. Metals, transition metals, and nonmetals. Metals are the elements that will form cations in your ionic compound. And cations are what has more positive charge because they lose an electron, therefore they have more protons. Next, in the ionic compound, you'll have a nonmetal, which will form an anion because it gains an electron in the reaction, so it has more negative charge than positive charge. So following the negative element, you'll add IDE.
Start.
But wait, there's more. So to really understand what kind of charges the cation ions get, you have to understand that each metal and each nonmetal and all the elements besides the noble gases are trying to become noble gases. So the metals will be losing the amount of electrons it takes to become their noble gas. Like sodium will be trying to lose 1 electron to become like neon. And bromine will be looking to receive 1 electron to become like krypton. Okay, so under the cation category, all metals will always be cations. They'll always have a positive charge because they'll always be losing electrons. But under the cation category, there is one type, metals, who will always have a concrete charge. It will always be the same. For example, sodium will always have a positive 1 charge because it will always be losing 1 electron. But there's also cations that can be formed by transition metals. And I have a question mark by transition metals because their charge can vary. Okay, and so here we have some examples. So this ionic compound, like I showed you earlier, salt, otherwise known as sodium chloride. So we start with the cation sodium with a +1 charge, then followed by chlorine, the anion. But I've crossed out the last part of chlorine because it's supposed to be followed by IDE, so it's chloride, which results in sodium chloride. So in my next example, you may be thinking to yourself, why is lead red? I just rhymed. That's besides the point. Lead is red because it is a transition metal, which means that we don't know its definite charge. So to figure it out, we must fill in what we do know. So we know that sulfur has a -2 charge because on the periodic table, it must receive 2 electrons to fill its octet rule. So that's a -2 charge. So when you go down, you go -2 multiplied by 1 equals -2. So whatever goes here has to equal 2 to cancel out -2 and equal 0. What could it be? It's 2. Okay, so you go down, -2, 2 equals 0. Whoa! Okay, so you go back here and fill in the Roman numeral. Because a Roman numeral is always after a transition metal to indicate its charge. Okay, so now we're going to do the next example, working backwards, where you have the name first. Oh my god, this is impossible. I don't know what to do. Wrong, it's super easy. Okay, so first, copper. You write down its element name. Wow, look at that. And then it literally tells you what the charge is, so you write the charge, 2+. And next you go over here, and we know sulfate is a polyatomic ion from our helpful periodic table. So we know sulfate is SO4 2-. So to figure out the subscripts, you just go down and see like what would make them cancel out. But in this example, it's really easy, so it's just 1 for each. So 2 plus -2 equals 0. We're done.